All right, so we got another one just like before. So graph the equation y equals 1 over x. Find any intercepts and check for symmetry first. So let's do that first. So find any intercepts. That's going to be interesting here. So x-intercept, how do you find an x-intercept? Well, you make y equal to 0. And so what happens though if you make y equal to 0? Well, 0 equals 1 over x. Okay. But now, if you try to solve for x, like what could you do here to even solve for anything? Well, you could multiply both sides by x. That's a legal move, right? But what happens when you multiply both sides by x? X times 0 just gets to be 0. And then over here, those x's get canceled out and you're just left with 1. You get 0 equals 1. And so we get no solution. So basically what we're saying is if there was an x-intercept, it's what we would get for x when we plug in y equals 0. But we just did that and we found that there's no solution. So that just simply means there's no x-intercept. There's none. And then when we go and we try to find the y-intercept, well, what's going to happen? We make x equal to 0. So we go y equals 1 over 0. And when you divide by 0, you can't divide by 0. So that's also no solution. So this graph has no x-intercepts or y-intercepts. Because when we try to solve for them, we just get problems or we just get no solution. So that just means there are none. And then check for symmetry. So when we check for symmetry, this is an actual function, so I'll rewrite it as an actual function. And then I'll say when we go to find, so we plug in negative x. We find f of negative x. Well, we plug in negative x, we get 1 over negative x. But if it's just negative in a fraction, very important to remember that negative can be anywhere. Top, bottom, outside, doesn't matter. So let's rewrite it with it on the outside. That way we can notice that this is negative f of x. It's just negative the original function. So what we found is that f of negative x is equal to negative f of x. That means it's an odd function or has origin symmetry. So we should be able to take that bottom left part, flip it up and over, and it should land back in on itself. Okay, so none of that actually allows us to start graphing it yet, but we can make the table. So let's make a table of values, x, y, and let's plug in some numbers. So we already tried to plug in 0 and it didn't work. So let's maybe plug in 1. So what? It's 1 divided by 1. So it's 1. 2. 1 divided by 2. Well, 1/2. Okay, 3. 1/3. 4. 1/4. So what's happening here? If we start plotting these points, 1, 1, 2, 1/2, 3, 1/3, and so on, look at what's happening. It's getting closer and closer and closer to 0. But what's going to happen as x gets bigger? Is it ever going to get to 0? What happens if x is like 100? Well, it's going to be 1 over 100. It's still not going to be 0. So this graph, as we go this way, it's getting closer and closer and closer to 0. And then what happens as it goes the other way? So what happens if we plug in something like 0.5, like 1/2? Well, what's 1 divided by 1/2? Well, if you divide by a fraction, this is just good to know. If you have 1 divided by a fraction, you just flip over the fraction. So that makes it kind of a lot easier to see what's going to happen. That if we plug in 1/2, we're going to get out 2. And if we plug in 1/3, 1 divided by 1/3, that fraction flips over and you get out 3. So we go 1/2, 2, 1/3, 3. So look how actually like the exact same thing is happening on this side. That graph is going up and up and up, getting closer and closer to 0. But like we said, we can't actually plug in 0. Because this graph doesn't have an x-intercept or a y-intercept. It does not have a y-intercept because you're not allowed to plug in 0 for x. You'd get undefined. And so what this actually has here is what we call an asymptote. That's what you call it when the graph gets closer and closer and closer to the axis, but never actually touches. And that's what we have here. And we have the same thing going sideways. we have a vertical and a horizontal asymptote here. A vertical asymptote, because we cannot plug in x equals 0, and a horizontal asymptote, because, well, for one, there's no y-intercepts. There's no x-intercepts. So it has to approach the x-intercept, but never actually get there. And so that's what that side of the graph looks like. But then what's going to happen when we plug in negative values? Well, we actually already said down here that when we plug in negative values, we should be getting out the same number, just the negative version. So we know exactly what's going to happen. We plug in -1, we get out -1. We plug in 2, we get out -1/2. So, and we can visualize it too, that it's going to be the exact same thing, just flipped down here. And you know that makes sense because it has origin symmetry. And so that makes sense. And let's refresh what that means. What that means is, so we have our original function. If we flip that original function over the x-axis, and then we flip it over the y-axis, it just lands back in on itself. That's the definition of origin symmetry. And that's definitely what this has. So this graph is looking pretty good.